Hey everyone. Today, just wanted to go over our second lesson, which is all about impulse. All right, so let me just open this up. All right, so again, we are in our kind of school closure unit, which is all about momentum and collisions. If you finished lesson one, then you should have access to this lesson right now. All right, so today we're talking about impulse. All right, let's talk about impulse. Yesterday we talked about momentum. Again, an object that has mass and velocity will have momentum. Obviously, the more mass and more velocity it has, the more momentum it will have. Now, we specifically want to talk about where impulse falls in. So let's say you have a regular softball, right, about 0.6 kilograms, and zooming towards the batter with a velocity of 50 meters per second. What does this ball have? We know that it has mass. We know that it has velocity, which means that it has momentum, right? As we discussed in lesson one. Now, we know in softball, if you have a good player, when the bat is swung, you'll get kind of a piercing ringing sound, right? It creates a sound wave. And suddenly the ball is moving in the opposite direction. In this case, let's say the ball is now moving with 60 meters per second, going in the opposite direction of where it was thrown. So we want to talk about why and what is this that caused the ball to move in the opposite direction. So what happened? All right. This is a case where we get an impulse, right? Where the ball collides with the bat and now is moving the opposite direction. That moment is called the impulse. So impulse is a term within a system that's the overall effect of a force acting over a time. So basically, it's the moment in which a force is applied within a system and then causes a change in momentum. So again, in this case, softball's being thrown towards you. Your bat hits the ball, and now the momentum of the ball has changed, and it's going in the opposite direction. Right? That change in the momentum is the impulse. Okay. Another example would be, let's say, in a car crash. Let's say two cars are heading towards each other head on. Right? They both have momentum in a direction. They collide. I would say they then kind of bounce off each other, right? So now they still have momentum. The momentum's going in opposite directions. And that moment that they collided was the impulse. And the impulse is what created that change in momentum. All right. Now, if we want to know how to calculate impulse or calculate that change in momentum, we have a simple formula. All right, our symbol for impulse is the letter J, right? And impulse equals the force multiplied by the change in time. So let's say with a baseball bat hitting a baseball, right, you're going to use a lot of force in a very short amount of time, right? So let's say hypothetically that the amount of force you're swinging your bat with is 100 newtons, right? And it happens in 0.1 seconds, right? It would actually probably be more like 0.01 seconds, right? Because it's like a snapshot, right? Happens very quickly, right? You're going to get a very large impulse. Now, we want to talk about how are impulse and momentum related, right? When we have an impulse applied to an object, the momentum of that object changes, right? In some cases, the direction that that object is moving will change, right? Just like we talked about with the baseball bat and the baseball. When you hit the baseball, the direction that the baseball is moving is now changed, right? It's going to move in a different direction and with different momentum. Now, we're thinking about describing that motion mathematically, we can find that the impulse is actually equal to the change in momentum. All right, so we know that our formula for impulse is J equals F times T, and our formula for momentum is P equals m times v, right? So we find that the impulse equals the change in momentum. Now, for some of you guys, you may be a little confused as how is that possible? Well, we can just do a little bit of algebra to kind of figure this out. And this is kind of what happens a lot in physics. Yeah, so I'm going over here. I'm just going to do a little bit of writing in this case. All right. So let's say we start with our momentum, right? Our momentum formula. So you got P equals m times velocity. Wow. I'm not liking that. Okay, well, I want to do this differently. I should have rethought how I was going to do this. All right. Anyways, we know that P equals m times v. A little bigger for now. P equals m times v, right? We also know that velocity or acceleration is equal to velocity divided by time. So if we have momentum equals mass times velocity, and we multiply this by time and divide the whole thing by time, what we end up with is momentum equals mass times acceleration times time. Okay, in Newton's second law, it states that force equals mass times acceleration, which means that over here, this mass times acceleration can become force times time, which is equal to our impulse. I would have preferred to draw that out, but obviously that did not work out so well. So, right, we end up here, which means that momentum equals mass times velocity, which equals force times time, which equals impulse. Did it now. All right, moving on. Let's take a little example. Let's say you have a person, they're just going crazy with this quarantine and they want to jump off their balcony to kind of escape their home. Let's say it's a second floor balcony, right? So still not safe, but not a dangerous example. All right, so let's say this person jumps off their balcony and they hit the ground feet first, right? Their velocity was 7 meters per second coming down, and that velocity was brought to rest in 0.05 seconds. So they're basically landing with their knees locked in place. Let's say if their mass is 100 kilograms, what force was required to bring them to rest? All right, so we have a couple formulas here that we can use to kind of figure this out. So we know their velocity, right? We know the time, and we know their mass. So we want to start thinking about what formula can we use, knowing these things, to figure out their force? All right, so we know that, let's say, force times time equals, try it again, force times time equals mass times velocity. And if we're trying to figure out just force by itself, right, we divide both sides by t, which means that we have mass times velocity divided by time. And in this case, we know that the mass is 100. Can multiply that by the velocity, which is 7, and divide that by the time, which is 0.05. All right, so that's how we would set this up. Now, already set it up here, make it a little bit easier. You calculate it out, 100 times 7, get 7,000, divided by 0.05, 14,000 newtons. Now, 14,000 newtons is a ton of force. So you think about in this particular scenario, when a person is dropping to the ground with their knees locked, they're applying 14,000, or really the ground is applying 14,000 newtons of force on your body, which is a lot, right? Now, obviously, if you were to jump from your balcony, you would hopefully not land with your knees locked, right? What might you do? Person jumping with that same velocity would probably want to bend their knees to extend the amount of time that that force is acting on the body, right? So instead of landing with your knees locked, getting that full amount of force acting on the body, you would want to bend your knees, extending the amount of time that that force is acting on the body. So basically extending the amount of time of the impulse. What that does is it ends up lessening the amount of force acting on the object, which in this case would be the person. So you can see in this case, by extending the amount of time by 0.5 seconds, you get 1/10 of the amount of force. And this is also why, some action movies and stuff, you'll see when they drop from a high distance, right, they'll kind of go into a low roll because that's really extending the amount of time of that force, extending the amount of time of that impulse. Okay. The longer the time period for the force to act, the necessary force is going to be reduced. All right, let's talk about why any of this is useful. Again, we see this a lot in our designs, right? You see it in car designs. Cars have crumple zones, meaning that when they collide with an object, instead of just being rigid and having that impulse and the force of it just kind of go throughout the entire car, what they do is they create a crumple zone at the beginning of the car or front of the car that's meant to literally crumple, which sounds a little counterintuitive because you might think you want a car that will be sturdy, but in this case, the crumple zone extends the amount of time that that force acts upon the object, therefore reducing the force of that impact on the overall body. You see it with high performance shoes. Again, you get kind of squishier soles every time you have an impact on the ground. It's going to kind of cushion that force, right? It's going to extend the amount of time that the ground is acting on your shoe and therefore your body. Again, we can see in several different examples. You see those barrels of water or sand kind of on the highway. So if there's high collision impacts, instead of just going straight into the concrete where there's no give, it's going to go into those barrels of water or sand, which will extend the amount of force acting over time. Again, you might want to think about some other examples in which we see this change in momentum extending over a period of time. A couple other things. Again, I know some of you guys learn a lot better by reading. So there are a couple readings within this lesson. One of them, you can just click on the link here. There's also a little video here for calculating really the impulse by just looking at graphs. We're not going to get into that just yet, possibly a little bit later, but you can feel free to kind of work ahead. All right, there are a few quiz questions below. Go ahead and begin working your way through those. Again, you need to get them all correct in order to move on to the next lesson. You do have multiple tries. So again, if you're having questions on those, feel free to just send me an email. All right, stay safe, and I will see you guys in the next lesson.